Hey guys, today we're going to talk about triangles. We are going to go over two theorems that help us understand how to make a triangle, if a triangle is actually a true triangle, if it can be done, and also how to solve for angles and sides of triangles. So a triangle, remember, has three sides. It has three angles as well. So when we're talking about triangles, the first theorem we're going to talk about is the triangle sum theorem. And the triangle sum theorem states that all three angles of a triangle add to equal 180 degrees. So all three angles of my triangle add to equal 180 degrees. So if I have a triangle, angle 1, angle 2, angle 3. So we say the measure, by just writing an M, of angle symbol 1. Measure of angle 2. Measure of angle 3. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So angle 1, 2, and 3 add to equal 180 degrees. Remember, when we have a triangle, this little symbol right here is that 90-degree mark. So if I said this was 90 degrees and I said this was 30 degrees, and I want to know what this measure is, I'm going to say 90 plus 30 plus some number, x, equals 180. So I'm going to combine my like terms. I'm going to take 90 plus 30, which gives me 120, bring down everything else. It's a positive 120, so I'm going to subtract 120 from both sides. Cancels out. X equals 180 minus 120 gives me 60 degrees. So this angle is 60 degrees. Remember that little circle is a degree symbol. You don't type in that degree symbol for any of your assignments. You're just going to type in the number, but you are going to see that little symbol. So if I give you a question like this being that 90-degree symbol again, and if I say these two are both x, so I'm going to say 90 plus x equals 180. So I'm going to combine these x's together, combining my like terms. X plus x makes 2x. So I'm going to do 90 plus 2x equals 180. I've got to subtract 90 because it's positive from both sides, leaving me with 180 minus 90 gives me 90. Bring down what's left, which is my 2x. To get x by itself, I'm going to divide by 2, leaving me with x equals 45 degrees. So this angle is 45, and this angle is 45. Which means this is also an isosceles triangle because these two sides are going to be the same. Now if I had a triangle where all three sides are the same, you're going to take 180 and divide it by 3, which gives me 60 degrees. So, next theorem that we're going to talk about is called our triangle. Remember, it's all about triangles. Triangle inequality theorem. And this is about the sides of a triangle. This is about the sides of a triangle. So earlier we talked about the angles, now we're talking about the sides. So this says that the two smallest sides of So, and if they're not, if this is not true, then it is not a true triangle. So if I have a triangle, and it looks like this, and I said this is 4, this is 9, this is 6. I'm going to take my two smallest sides, 4 and 6. I'm going to say 4 plus 6 equals 10. I need this to be larger, greater than my largest side, which is 9. 10 is larger than 9, so this is a true triangle. This is an actual triangle that could be made. If I gave you something like one, 8, and 6, my two smallest are 1 and 6, so 1 plus 6 equals 7. I need 7 to be larger than 8. Since 7 is not larger than 8, this cannot happen. It is not a true triangle. This cannot actually be made as a triangle. Our sides would not touch, they would not connect. One of the practice assignments has it where it shows you the length and allows you to manipulate the triangle to make sure you can actually truly see how they would not touch. Hopefully these notes helped you. You will be able to find a picture of this in that notebook section on the, where you can find my notebook on the things that you can print. So that first module, you can find this under the notebook section if you need to actually see the picture. Hopefully this helped you with triangles. We are going to talk about how to find a missing side of a triangle in our next video, which is very similar to looking at our sides. So I will see you next time.